Hey guys, Savage Sullivan Math here. Today we're going to do some more work with Pythagorean Theorem. But in fact, we're going to take a look at it from a different lens. So we know that the Pythagorean Theorem only works for right triangles. And we remember that a right triangle is a triangle that has one right angle. So what if I asked this question? Do these three side lengths form a right triangle? So if we're given a right triangle with side lengths, we can use the Pythagorean theorem to find a missing hypotenuse or a missing leg length. The other way we can use Pythagorean theorem is to prove whether or not a triangle is right by just being given the three side lengths. So if we know that Pythagorean theorem works only with right triangles, that would mean that if I plugged these three side lengths into the Pythagorean theorem and it was a right triangle, then it should work. So just a quick refresher, we all remember that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the side lengths, or the leg lengths, I should say, and c is our hypotenuse. So if this is in fact a right triangle, that means that the longest side length would be the hypotenuse. So 65 is the biggest number in this list. So we're going to go ahead and we're going to plug 65 in for C. And since it's squared, we are going to square it. A and B are also going to get squared. So again, doesn't matter if 33 is A or 56 is A. So I'm just going to go ahead and I'm going to say 33 squared plus 56 squared. So if this equation comes out to be true, then we know that this is a right triangle. So let's go ahead and see. 33 squared is 1,089 plus 56 squared, which is 3,136. Should equal 65 squared, which is 4,225. Let's simplify the left-hand side of that equation. 1,089 plus 3,136 is in fact 4,225. So since we ended up with an equation that is true, meaning the same number on either side of the equal sign, that must mean that these three side lengths, yes, do in fact form a right triangle. So that tells us that, yes, it is a right triangle. Pretty exciting.
Nice work, Mrs. Savage. Here's another example. Again, we're doing the same thing where we are looking to see if these three lengths would create a right triangle. So we need to make sure that we pick the longest side for the C or the hypotenuse. Well, I know that 11 is longer than 9, but I have to think a little bit about the square root of 115. So over to the side here, I'm going to just think about the square root of 115. I don't know what that is, but I do know that the square root of 115 falls between the square root of 100, which I know is 10, and the square root of 121, which I know is 11. So I know that the square root of 115 is somewhere between 10 and 11, and therefore it is shorter than this 11, which means that this 11 has to be my C value. I can make the 9 my A and the radical 15 my B. So when I plug it into the formula of A squared plus B squared equals C squared, which is the Pythagorean theorem to see if it forms a right triangle, I will plug in 9 squared plus radical 115 squared, and I'm going to say that's equal to 11 squared. 9 times 9, or 9 squared, is 81. Radical 115 times radical 115. Remember, taking the square root and squaring something, those are inverse operations, so those cancel out. So radical 15 times, radical 115 times radical 115 is just 115. And I know that 11 times 11 is 121. So when I simplify the left-hand side of this equation, I get 196 is equal to 121. That doesn't work at all. So do these three lengths form a right triangle? No, they do not. If you found this video helpful, please like and subscribe.